Today we're going to begin Unit 9 by exploring circles. And the first part of this lesson is the circumference and area of a circle, which are two things you have previously learned and probably spent quite a bit of time on. So as a quick refresher, the circumference of a circle is given by two different formulas. You can either use the radius or you can use the diameter, whichever one you feel comfortable using or whichever one you feel like using. So the more common formula is their circumference equals 2 times pi times the radius. If by chance you are given the diameter, you could use the formula circumference is equal to pi times the diameter. So you don't use both of them, you use one or the other, whichever one you want to use. And when you are done writing your answer for the circumference, you have to make sure you include units. And that would be inches or centimeters or miles or whatever your unit of measurement is on the original example. The area of a circle is specifically using the radius. If you are given the diameter, you have to divide that diameter by 2 in order to get back to the length of the radius. So the area of a circle is given by the formula of pi times the radius squared. And same thing goes for this. You make sure you include units, and for area, it's always going to be square units. Okay, so I want you to practice circumference and area by yourselves. Again, this is something you've already seen, so please complete the next section by yourself. The directions do tell you to leave your answer in terms of pi. That means you multiply everything together except for the pi value. Your final answer should look something like 2 pi square inches. So pi is always in your answer. You do not multiply that together. That's what it means to leave in terms of pi. So please press pause on your video, try these problems, and then you can come back and you can watch me do them out. For this next section of examples, we are going to be working backwards. So given the circumference or the area, determine the radius for each circle. Starting with number 1, we're given the circumference. So as a reminder, the circumference is going to be equal to, I'm going to use 2 pi r. Of course, you could use pi times the diameter, but The directions are specifically asking us to find the radius, so I'm going to use 2 pi r. I know that the circumference is equal to 18.84, so I can substitute that value in for c. This is equal to 2 times pi times the radius. We want to solve for r. We are trying to isolate this value. So I'm going to divide both sides by 2 pi. This is going to eliminate 2 pi on the right side. I am going to type this expression into my calculator. Make sure when you type this into your calculator you put parentheses around your denominator, or else you're going to get the wrong answer. So everyone should try their answer, see if you get the same as me. When I type it in, the radius is approximately 3 inches. And for number 2, I'm going to follow a similar process, except for this time we are given the area. So I'm going to use the formula that says area is equal to pi times the radius squared. I know the area is 314, so I can substitute that in for my value of a. I need to solve for r. That requires me to divide both sides by pi. That eliminates pi on the right side. When I type 314 divided by pi into my calculator, I end up with 99.95 is equal to r squared. I am still solving for r, so in order to isolate one single value of r, you have to take the square root of both sides. And when I type this into my calculator, my value of r is approximately 10.0 centimeters. Next, we're learning about arc length, which is the measure of an arc in degrees. Arc length is a fraction of the circumference. So here's the equation of arc length. The length of arc AB, which is, as you can see, this arc here. So length of arc AB, make sure you use the correct notation, is going to be the measure of arc AB, same as the central angle, divided by 360 times the circumference. And that's going to give you just that portion of the arc length. So if you're trying to find the length of a piece of a circle instead of the entire circumference, this is the equation that you use. So let's go through a couple of examples. So for the first example, let's mark a couple of things. We're looking for the arc length shown in black, which is this arc here. So we're looking for that arc length. We know that this central angle that ties to that arc is 90 because I see my 90-degree symbol right there, which means this arc measure is also 90. So when I start to fill in my formula, besides from knowing the central angle, I also need to know the radius. If the diameter is 16, that's telling me that the radius is equal to 8 inches. So now I have enough information to fill in the equation for the length of arc XY. And length of arc XY is going to be determined by the measure of XY divided by 360 multiplied by the circumference of 2 pi r. And don't forget that the measure of arc XY is going to be in degrees. When I simplify this, I substitute in 90 degrees for the measure of XY divided by 360 multiplied by 2 times pi times 8. Now remember that technically this second part is over 1. It's a fraction over 1. So when you multiply everything together, you want to multiply all of your numerators and then you multiply your denominator. As far as the numerator goes, I can multiply 90 times 2 times 8. I'm going to leave pi in the form of pi. But when I multiply 90 times 2 times 8, My new numerator becomes 1440 times pi divided by 360 times 1, which is just 360. And then we're going to see if we have a number that goes equally into the numerator and the denominator. And in this case, it actually works out perfect. 360 goes into itself once, goes into 1,440 4 times. So our final answer is 4 pi, and this is inches. So the length of xy is 4 pi inches. Okay, the directions tell us to leave our answer in terms of pi. I'm just going to highlight those directions right here. Leave answer in terms of pi. This is what that looks like. It means you do not multiply in your value of pi. Pi remains in your answer. So the pi symbol should be in your answer. You should not be multiplying that in. So if we go back up and we analyze this, notice how at this step I multiplied only my whole numbers. I highlighted them in green and I just drew a pink arrow to them. By doing that, I get my whole number multiplied by pi over my denominator. All right, let's take a look at number 2. So for number 2, we see we have our measure, which is 240. That would be our arc measure. And I also see that I have our radius, which is 15. So when I substitute into the formula for the length of xpy, because it's a major arc, it's greater than 360, this is equal to the measure of xpy divided by 360 times 2 pi r. When I substitute our values into this equation, xpy measures 240 degrees divided by 360 multiplied by 2 times pi times the radius of 15. I'm going to imagine that my second expression is over 1, and I'm going to multiply in my numerator all of my whole numbers, my integer values. 240 times 2 times 15 is going to give us 7,200 times pi divided by 360. And 360 actually goes into 7,200 20 times. So my final answer is going to be 20 pi. And my units here are centimeters. So 20 pi centimeters is the length of that arc. Remember to keep pi in your answer. Do not multiply that out. For the next section, we're working backwards. So we are looking to determine the radius of the circle K. It looks like we are given the central angle. It looks like we are given the arc length. So I'm going to use my equation. I'm going to work backwards and I'm going to solve for r. So here is the arc that we know the length of right there. I'm going to add a point to this just for naming purposes. It's a major arc. You need 3 points to name the arc. So let's add point Z. If we use the equation, length of JZL is equal to the measure of JZL divided by 360 times 2 pi r. Let's fill in everything we know here. We know, or I know, that we don't know the radius because it's what we're looking for. What I do know is the length of JZL is 56.37 feet. I know that the arc length, or the measure of the arc, is going to be 340. divided by 360 multiplied by 2 times pi times r. And we're solving for r. In order to solve for r, what I am going to do is on the right side of the equal sign, I'm going to multiply all of my values together except for pi, and, except for the radius. So I'm going to multiply all of those values together. This leaves me with 56.37. When I multiply 340 divided by 360 times 2 times pi using the pi key in my calculator, I end up with 5.93. And that's multiplied by r. Now, I'm solving for r, so in order to isolate the value of r, I'm going to divide both sides by 5.93. By doing so, 56.37 divided by 5.93 gives me approximately 9.51 feet for the radius. So this is working backwards to find the length of the radius. Okay, if we go back up and I talk about the steps a little bit, at this step here, because we're solving for r, we have to multiply everything together except for that value. That way we can get it by itself. So that's what I typed into my calculator. Okay, I want everyone to try number 2 by yourself, and then come back to the video for the answer. Next up, we're looking at the sector of a circle. A sector of a circle is a region bounded by an arc of the circle and 2 radii to the arc's endpoints. You name a sector using one arc endpoint, the center of the circle, and the other arc endpoint. So you're finding the area, say, of this small segment here. So you're finding the area of one slice of pizza instead of the whole pizza. So the area formula states that the area of the sector AOB, which is A to O to B, is equal to the measure of arc AB divided by 360, so same as the previous formula, but this time we multiply it by the area, so times pi times the radius squared. So if we jump right into the example below, we are looking for the area of sector GPH, which is this sector here. This is the area that we're looking for. So in order to find this area, I need to know the measure of the arc, which is 72. And I need to know the radius, which is 15. The equation says that I need to fill in the measure of arc GH divided by 360. And I'm going to multiply this by pi times the radius squared, which this formula is the area of a circle. When I substitute my values into this equation, I substitute 72 for the arc length, for the measure of the arc, divided by 360 times pi times the radius of 15 squared. Now we are leaving our answer in terms of pi because that's what the directions tell us. So we're going to do the same thing that we did on the last example set. We're going to imagine that this is over 1. And in the numerator, we're going to multiply just our whole numbers together. So we're going to multiply 72 times 15 squared, which gives us 16,200 divided by 360 times pi. Now we're going to see, is there any two numbers that simplify this fraction? And actually 360 goes into itself once, and it goes into 16,200 45 times. So our final answer here is 45 pi, and this is square centimeters. Don't forget your units. Remember, you multiply your integer values. You're going to end up with a large fraction. You have to see what divides evenly into them. Usually they're pretty nice fractions to deal with, so just test out, see what you can divide. Make sure your final answer includes the pi term. That's what the directions are asking for. Okay, and number 2 is actually typed out for you. It doesn't give you a diagram, but it does give you all of the necessary information. So this one says a circle has a radius of 4 inches. What is the area of the circle bounded by a 45-degree minor arc? Leave your answer in terms of pi. So if we know 45 degrees is the measure of the minor arc that's associated with the sector, we have 45 divided by 360 multiplied by pi times the radius of 4 squared. So 45 divided by 360, we're going to multiply our numerators of 45 times 4 squared. That gives us 720. 720 divided by 360 multiplied by pi. And 360 goes into itself once, goes into 720 2 times. So our final simplified answer here is 2 pi, and we're dealing with inches, so square inches. And that is your final answer. Okay, please try the on your own section by yourself. I am going to complete this section, so when you come back to the video, you will see my work done out, or you will see me do my work out. Your answer should be in terms of pi, so make sure you always simplify this fraction. So at this step right here, you're simplifying that fraction. Please let me know if you have any questions, and have a great day.